For long division of polynomials, you'll recall the 3 steps that I always make you guys use is just to divide the fronts, multiply, then last we can just switch the sides and add. And then we just keep repeating that until we get the remainder. Switch. So let's just set this up as a long division problem. We have 2x plus 3 on the outside, and inside we'll put the 8x to the 4th plus 16x to the 3rd plus 2x squared minus 14x minus 7. So the first step is divide the front. So we look at the front on the inside, which is 8x to the 4th divided by 2x, and that goes on top. So 8 divided by 2 is 4, and then x to the 4th divided by x is x to the 3rd. Then we multiply by here, distributing to both, and line them up with their like terms. So 4x to the 3rd times 2x is 8 and x to the 4th. And then also multiply to the 3. So 4x to the 3rd times 3 is plus 12x to the 3rd. Then whatever we just multiplied to, we switch the signs on both of them and add. So here they cancel out, and I'm left with 4x to the 3rd. And if I keep adding straight down, this adds to nothing, that adds to nothing, this adds to nothing, so they just come straight down. Plus 2x squared minus 14x minus 7. And we just repeat that process till we get to the very end. So let's divide the fronts again. 4x to the 3rd divided by 2x is going to be 2x to the 2nd. Multiply, so 2x squared times 2x is 4x to the 3rd. 2x squared times 3 is plus 6x squared. And then we just switch the signs and add straight down again. Oops. Switch the signs. Yeah. So these cancel out. 2 minus 6 is 4x squared. Negative. Minus 14x and minus 7. Let's do this again. So divide the fronts. Negative 4x squared divided by 2x is minus 2x squared, or 2x I mean. The negative 2x times 2x is negative 4x squared. Do the next one is negative 2x times 3 is minus 6x. And then we switch the signs and add. So these cancel out again. Negative 14x plus 6 is going to be negative 8x minus 7. And one last time. So negative 8 is the new front. So negative 8x divided by 2x is minus 4. And then so I have negative 4 times 2x is negative 8x. Negative 4 times 3 is negative 12. And last we switch the signs and add. So 12 plus 7 is 5. And there's my remainder. So I know my answer is going to be the entire top that we have plus 2x squared minus 2x minus 4 plus the remainder over what I was dividing by, 2x plus 30. So which one is that? That looks like it is A. Make sure you're very careful because they all look very similar. Alright, so for this one, all we're supposed to do is really just write an equation that represents this table here. And it's an exponential equation. So if you recall the form of an exponential, it's always the initial value, A, times B to the x power. So the exponent's always up here. So in this case, our initial value is what we're starting with. This is the number we're multiplying by, my factor, my growth factor, right? Because it has the exponent, that's what we're multiplying by. And this is the exponent. So looking at this table, well, we know what we start with. At day 0, the very beginning, we start with 50. So the first number is just 50. And then we look at what are we multiplying by over and over again. It looks like 50 times 2 is 100. Times 2 is 200. So it looks like we're multiplying by 2. And then t is the time, so or how many times we do it is time and how many days we go by. So which answer is that? Oh, that's just C. Here we want to solve this problem. It's a quadratic, so three ways that we learn to do this is 1 by factoring, 2 by completing the square, or 3 by quadratic formula. Now, if they don't tell us completing the square, quadratic formula is always easier than that. And by looking at the multiple choice answers, it's probably not going to be factorable either, because these are really ugly answers. So let's just go straight to the quadratic formula. So if you recall the actual quadratic formula, it's 2 parts put together. The opposite b over 2a, and then on top we have the plus or minus the discriminant. So I always like starting with the discriminant first, and then adding it into that equation afterwards. So let's start with the discriminant, which is b squared minus 4ac. Right, so plugging this in, our a is 3, our b is 4, our c is 4. So I'm going to get b squared, which is 4 squared, minus 4 times a, which is 3, times c, which is 4. And if I work this out, I get 16 minus 12 times 4 is 48. And if I subtract that, I get negative 32. So that's the discriminant. So let's plug it into our equation, our entire formula. So that's going to be x is equal to opposite b over 2a. So let's get that vertex part in. So that's negative 4 over 2 times a, 2 times 3. And then on top, we have plus or minus the discriminant, negative 32. Now, all we have to do is simplify. So let's start with, well, we can multiply this bottom, but also simplify this square root. So remember, we want to pull out a negative as an I, since it's square root of a negative, we know it's imaginary, and also simplify this 32. So I know that this is going to be negative 4, plus or minus. We know there's an I coming out. And also, I know 32 is 16 times 2. I know the square root of 16. I don't know the square root of 2. So we'll pull out the square root of 16 as a 4. And inside, since we don't know the square root of 2, we leave it as square root of 2. And on the bottom, we have a 6. Then, just make sure you distribute this to both terms, and then reduce the fractions. So this is negative 4 over 6. It distributes to both, and here we have 4i root 2 over 6. And then we can only reduce the stuff on the outside. We can't reduce anything inside the square roots. That's trapped inside. So when I reduce this by dividing them both by 2, we get negative 2 over 3. And here we get 2i root 2 over 3, which is, well, first it's imaginary and has this in front. So the answer is D. Alright, so even though this one is a quadratic and we're going to be having a U shape, how we can tell how narrow or wide it is very similar to when we were looking at finding the width of an absolute value, the V shape. So we're going to treat it the same way just so we can answer this question. So where this 5, 6 was kind of like the slope before, now even though it's not the exact slope because it's curved, it still tells us if it's narrow or wider. So one way we can do this is kind of graphing it out. So I'll just draw a quick graph here. And I know the slope, so-called slope on this is up 5 over 6. Which is right there. So I'm going to draw it as a V, even though it's supposed to be a U shape, a parabola shape. We're going to draw it like this, so that way it's easier to see. And make sure you read the question carefully. It says, which of the following graphs is wider? So we want to see something that's out here in the wider area, not inside. So the first one has a slope of 2 over 1. So let's try that one, up 2 over 1. And you can see, oh, nope, that's narrower. So let's move on to the next one. This one's negative 3 over 7, but we're not going to go downwards. We don't want to go down because then it's hard to compare. We'll just go up 3 over 7. Up 1, 2, 3. 1, 2, 3, 4, 5, 6, 7. And I can see, yeah, this one looks like it's getting wider. So that looks like it's going to be my answer, but let's just double check the last one just to make sure. If I go up 3 over 2, it's up 1, 2, 3 over 1, 2. And we see, yeah, this one is narrower also. So my answer is going to be C.